Okay, so I'm working on the first problem. The first problem says we've got a sphere and we want to fill it up to a certain height. Okay, and in our example, the height is r over 4, and the sphere has radius r. So what we do to do these type of problems is we chop them. We chop up the sphere into pieces and measure the area of each chopping and add them up. See, right here is an example chopping. I've chopped it here and I get a circle. This slice of the sphere is a circle, and then we'll find the area of that, and we'll find the area of the next slice and the area of the next slice, and then we'll add them up and we'll have the volume at that height. And here's the general formula for it. The volume of the sphere from the bottom limit to the top limit, 0 to r over 4 in our case, of the area of the slice at the height y. So in our case, we just need to know what the area of this circle is. We need to find a general formula for what this area of that circle is when we slice it there. And note that it's going to depend on y, because when y is 0, there's no little circle. We have no area. When y is just a little bit above 0, we have a little tiny circle. When it's higher up, we get bigger circles and so forth. So this area is going to depend on y. The trick is to find the formula for that slice. So let's see if we can do that now. So notice that if we draw a triangle from the center of the circle down to the bottom, if we draw a line down there, we create a triangle. Okay? Well, that's how we're going to find our radius of that circle. Because remember, we need to find the area of that slice, but that slice is just a circle. So we can use the area of a circle formula, pi r squared. Okay? So we have the Pythagorean theorem to solve that. We know that this is the side we're looking for, it's called r. This side is going to stay fixed because the radius of a sphere is always a fixed distance. So that is just going to be r. Let's see in our formula here. And that r is in our formula here. And this one is the only hard one to figure out because it just is not immediately obvious. But think about it. If we set our coordinate axis as y at 0 right here, then this side of this triangle is going to be r minus y, because this whole distance is r, and whatever y is, we're going to subtract that from r and find our radius. Okay, so that side is r minus y, and we put it into the formula. Then we solve for this r, and we get this right here. This is an expression based on whatever y is that gives us the radius of that circle. And then we know now that the area at the y slice is just pi r squared, and we plug that in, and there we go. So that's the hard part, is figuring out how the hell we can express the area of a slice in terms of y. Hold on, I'm switching pages here and there's wind. So remember, we go back to our original formula. The height from a to b of the integral ay dy will give us the volume of this sphere. Well, we're going from height 0 to a height of r over 4, and here's the a of y we just figured out. And there's the integral there. See right here, I took this and foiled it out. The r's canceled, and I'm left with this, and then I just integrate. And there you go. I'll just stop it here and you can follow that along if you're having trouble with the integration, but I hope that video helped. That's basically in a nutshell how you do that problem.